Okay, guys, we are officially on our last shape of the year. Actually, the last concept we're going to do. So we've done lateral area, surface area, and volume of prisms, cylinders, cones, spheres. Now we're going to do pyramids. This will probably be the hardest of the shapes that we have to do. All right, so I'm pretty sure you guys all know what a pyramid looks like. It has a vertex up, point up at top, and from there, you're going to run a line segment down to each of the corners of the base. So this is the base, which in this problem is a square because all the sides are congruent. It doesn't look like one because you have to draw it kind of angled to get that three-dimensional effect. But that is the square on the bottom there. It will not always be a square, and that's what's going to make it harder. This is going to be an octagon or a pentagon or hexagon. That'll make the problem a little bit harder. But we're going to start off today with just all square bases. Okay, so here's the thing that's going to go on. From the top of the pyramid, I'm going to give you guys one of three lines. If I give you one of the lines that goes to a corner of the base, this is called a lateral edge. Lateral edge. There's two other options that I'm going to give you guys. Here's another one. If you look at the side of a pyramid, from any of the sides, they're triangles. If I go straight down the middle of one of the triangles at a 90-degree angle, that is slant height, L. So that's just like it was with a cone. It's the slanted height because the side is slanted. That's going to be in our formulas. Here's another thing that's going to be in there. If I go from the top straight down to the middle of the base, the dead middle of the base, that is the height of the figure H. I'm going to give you one of these three things, either H, L, or the lateral edge. The lateral edge, very important what I'm about to write. Not in a formula. Which means if I give you the lateral edge, you better never put that in a formula. L is in formulas, H is in formulas, but lateral edge is not. You're going to use it to get L, and then you'll be better off. Okay, so let me give you guys the formulas, and then we'll start looking at a couple examples. All right, first thing, lateral area. So LA is 1/2 capital P L. That is an L. Now, we already know capital P means. It means the perimeter of the base. So in this case, that'll be a square. Remember, it won't always be a square, but here it is. So that'll be pretty easy because all the sides are the same. All right, total area. Just like every figure we've done, it's going to be the lateral area plus, now we got to add in the base. So that's big B, area of the base. Again, for a square, that's just length times width. That's going to be pretty easy. Last one, volume. Volume is 1/3 big B, which you'll already have, times H, which you're going to have to find sometimes. Those are your three formulas. Okay, now let's talk about what we're doing. What we're going to look to do, just like we've been doing, is we're going to create right triangles in this figure so that we can find the things that we need, and we won't do trig. This will be all Pythagorean theorem for pyramids, so that you don't have to worry about any trig. All right, let me show you the triangles. There's one of the right triangles right there. I'm going to block off the rest of the pyramid. See how the L comes straight down at a 90-degree angle? Then from there to there would be half of a side, then the lateral edge. Those three are going to make a right triangle that you're going to do Pythagorean theorem sometimes with. So we're going to draw those triangles right now so that you guys can, I can reference them. So you're going to have triangles created. So there's going to be two of them. 2 triangles created. One is going to be that triangle I just showed you. I'm going to call that triangle number 1. Right here. So triangle number 1, right there. So that's this guy right here. So the L comes straight down at the 90-degree angle, so that'll be there. This measurement from here to here would be half of the side. So if I tell you this whole side's 10, that would be 5. So we're going to call that half of a side of the base. And then the hypotenuse coming up, that would be this, the lateral edge. Okay, that's triangle number 1. That's one of the triangles we're going to work with. All right, triangle number 2. This one sometimes people have a little bit more trouble saying. That's going to be the height comes straight down, so that's going to be 90 degrees. Then from the height straight over to the slant height. So it goes down here, then from the middle over here to the middle of that side, and now the hypotenuse is going to be the slant height. So I'm going to try to block it out. That's the right triangle you're talking about. Straight down, height's the vertical, 90 degrees, over to there, and then from there up is the hypotenuse. So that'll be what I'll call triangle number 2. So if you guys are doing note cards and stuff to keep up on all these formulas, these 2 triangles should be on there. So triangle number 2, like I said, the height comes straight down, so there's H. The slant height's the hypotenuse, so there's L. This measurement from here to here in a square is going to be half the side, but when we start doing like hexagons and stuff, that's going to be the apothem. Because look where it goes. It goes from the middle of the figure to the middle of a side. That's just like the apothem used to do. So like if I drew you an apothem real quick, you know, remember like this was a figure that when we did, if I go from the center to the middle of the side, that was known as the apothem. That's what we're drawing here. We're going from the center of the square to the middle of the side, so that's the apothem. A-P-O-T-H-E-M. Okay, so you're going to use these 2 triangles to find everything you need to do these formulas. Okay, let's go to our first example. All right, so if you guys are having trouble drawing this, let me show you what to do. First, you draw the base. So even though that's a square, we have to draw it looking like a parallelogram. So you're going to go like this when you're going to draw these. Do it slanted. Then go to the middle, go up and put a point, and then just draw to each corner. So there to there, there to there, there to there. And this one I like to do dotted because technically it's behind where you're not supposed to be able to see it. And that's the figure we're looking at. And even though it doesn't look like all 4 of these are equal, they are, because that's how you have to draw it so it doesn't look weird. It's not like you can't draw a square and then do that, because that would look weird if you tried to do it just an actual square. So we draw it looking like this to get that whole 3-dimensional feel. Okay, let's get back to our problem. So there's our figure. First thing I want you guys to do every time, right off the bat, is identify what it is I gave you. That 20, that's one of 3 things. It's either the lateral edge, the slant height, or the height. You need to know which one it is, because if you think it's the wrong thing, you're going to get a bunch of things wrong. So zoom out a little bit. We got to figure out what that 20 is. Now look where it is. It's not one of the lateral edges, because I drew all the lateral edges in blue. They go from the top to the corner of each side of the base. So that doesn't do it. That goes down the middle. That 20 is your L. So you need to know that. 20 is L. All right, so now let's see if we can do any of these actual problems. So I'm going to zoom out so we get to the formulas. So we have lateral area first. It's 1/2 PL. So 1/2 the perimeter of the base times the slant height. Now the base for this is going to be easy because that's a square. So if I want the perimeter of a square, I'm just going to add up all 4 sides, and they're all 8. 8, 8, 8, and 8. That's 32. So there's my perimeter of base. It's not a formula. It's just add up all the sides. The slant height I gave you, that's 20. So put a 20 in there.